Hello again, everyone. Welcome to our next talk. This one is with Hans-Joachim Edert and Matteo Landro, which is ModelOps Automation with SAS Viya. I'll introduce them briefly. So, without a doubt, putting analytics into action is one of the biggest challenges across industries. To generate business value from analytics investments, organizations need to adopt ModelOps practices to streamline the way they validate and deploy analytical models. However, implementing a ModelOps approach is not a simple task as it involves many technical and non-technical, i.e. cultural or organizational aspects. In this session, we will discuss some of the technical key principles of ModelOps, and we will demonstrate a pipeline approach to quickly move from development to test and production using a mix of Python, SAS Viya, and other CI/CD tools. Hans, Matteo, feel free to start. Thank you.
Okay, thanks a lot. I hope the audio is fine. Okay. Thanks, Stefan, for kicking off. Since you nicely introduced us, I think we can skip this part and move straight on to the agenda. So today, our talk will be focusing on ModelOps, just as Stefan already said. And this talk will start with a short introduction, which will be done by me. We will introduce some tools and the general concept, and we'll then move on to talk about what ModelOps actually means for data scientists and for machine learning engineers. And that's the part that Matteo will cover because he's our data scientist. Throughout our talk, we will be using a sample analytical model, a sample application, to illustrate to illustrate how ModelOps actually could look like in real life. And this is the sample application I just mentioned. It's taken from the insurance industry, and I think it covers a fairly common scenario. Imagine that you want to improve the decision-making process for credit loans, and you do that by adding a back-end scoring service. So you're adding analytics. So when a customer requests a credit loan, your analytical model would score the customer and would return a recommendation based on the input that you send to the model. Now, where does that model come from? Well, I mean, you as a data scientist have worked on it and at some point made it available to your production system. And this is actually where ModelOps comes into play. ModelOps is how these golden arrows that you can see on the screen are implemented from a process and a tool perspective. ModelOps is the way how you streamline these processes of bringing your model into production and returning feedback data from them. So why do we actually need yet another one of these OPSy things? You know, there's DevOps, DataOps, GitOps, MLOps, and a couple of others possibly as well. Well, the common point of all of these approaches is that they try to improve efficiency and streamline the collaboration between isolated teams. Let's, for example, say developers and operations people. So when looking at ModelOps in specific, the focus shifts a little bit. It's not about the model development phase, which is of most concern, but it's the point when you need to hand over your model and when you want to deploy it to a production environment. And that's actually the very moment where your model starts bringing benefit to the company that you work for. Most companies that we have met really do not have a truly automated way of doing this. Most of them are actually still relying on a lot of manual steps, and this, what is often called the last mile, is often a really painful experience. It's slow, and everybody involved really suffers from it. And to improve this process is at the heart of the ModelOps approach. And just to emphasize on this, the idea of automating analytics is the key point of this ModelOps idea. Automation can happen in a lot of different ways. It happens, for example, when you automate your model development to operate on your full portfolio instead of handcrafting a single model for a single product. And it should also take place when testing and validating your models. And this exactly is what we want to cover in our talk. Let's briefly talk about the tools perspective. While ModelOps is an approach describing processes and even a cultural change, you still will need tools to implement it. And Git and Jenkins are typical examples for that. In the demo that you will see us working with Python to create a classification model. But we will also use a model management tool which belongs to the SAS Viya software stack. So actually, what is this SAS Viya? To be short, it's a platform for integrating analytics and data management and dashboarding. It has a couple of computation engines built in. One of them is a distributed in-memory engine, which is very fast and capable of running in-memory analytics. We do have a lot of state-of-the-art machine learning and deep learning algorithms with us. We do have a lot of interfaces, so the platform is open to integrate with open source and other languages and tools. But we also have our own set of visual interfaces, so we do offer a unified user experience. And finally, all of that gives you an end-to-end approach for analytics, and that allows you for a shorter time to market. While we will cover a coding approach today, and you will only see one specific tool of the SAS platform, we wanted to show this slide just to remind you or to make you aware that this platform actually has much more capabilities than just the model management part. All of these capabilities are actually centered on analyzing and preparing data of all kinds and all sources. We have reporting tools, we have pipelining applications, and we have, of course, we do have code editors. But again, for today, we'll just focus on the model management pieces. And with that, I would like to hand over to Matteo to talk a bit about the data scientist perspective.
Yes, thanks, Hans. I will start sharing my screen. I hope you can see that already. Yes, okay, now I can see it's moving, perfect.
Yeah.
Okay, so yeah, so after some theory, some very, very brief theory on ModelOps, and after this really short introduction on SAS Viya, now we can start actually talking about models, how we can build machine learning models. So in this section, we will take the perspective of the data scientist, and we will see how we should train our models following the ModelOps principles. So we're sure that we will be able to say what you actually see here, that we have developed the best model, right? So let's get into that. So Hans actually just mentioned the end-to-end life cycle, right? So what do we mean by that? Basically, when you build a model and you want to deploy your model, you have to follow some steps, right? And we can consider three main phases in this life cycle. We have the model development phase, in which, of course, we take our data, we do some exploration, then we train the model. Then we go to the model deployment phase, in which of course, we need to save our model maybe in a model repository. We deploy the model, but then the story doesn't end here. Of course, we need to make sure that the model keeps performing well over time. So we need to monitor our model, and in case we need to retrain the model. And you see, this is not a finite process, it's a continuous process, right? Because in case you need to retrain your model, maybe you need to go back to this initial state and refollow the process. We also have an additional piece of this cycle, which is the decisioning piece. We will not cover this part, but I think it's interesting to mention that, of course, when you build a model, you can also decide to embed your model in some decisioning process, so you can use the model and take action based on your model results. So this is an additional step on the life cycle. We will not see that today, but I think it's worth mentioning it. Okay, so right now we are right here. So we imagine we have our data and we have to train the model. How can we do that? So we said, actually, okay, we will take the data, we will do maybe some data preparation, and then we will train our model. So this is the model development phase. So something important to remember here is that training a model is not the same as applying a model, scoring the model on new data. Why that? When you build a model, when you train the model, you write, if you're a coder, you write a training code, right? But then, of course, it's different than scoring, applying the model to new data. You have to have something different here. And you have also to remember that the environment when you will run the model eventually, so the production environment, could be different than the training environment. So you need to be you need to do some tests before saying that the model is ready and move to the model deployment phase. So in this part, really, we just need to remember that we will, in the model development phase, we will first build our training code, but also we will also need to create the score code. Okay. That said, let's move to our first part of the demo. So this is what we're going to show you today to end up with the nice interface that we saw at the beginning with Hans. What we will do in the demo will be to train a model in Python using a Jupyter Notebook pod. Then we will register the model into our model repository place. And then we will publish this model into a container. So this is the entire demo. Right now, we will focus on the first part. So for the data scientists, we need to train the model, right? So let's go to that part. I will change, and I hope you can still see my screen. I'm accessing my data science workbench. Basically, this is the environment I can use to spin up a container with my, let's say, training environment. Okay, so for example, if I go to here with this application, I can decide to spin up a container with a specific engine behind. I can choose between SAS, Viya, Python, and R. Okay, so in this case, I will use this kind of environment with Python installed. I actually already done it, so we don't need to do that now. But if we go to the pods that are really already available, I can see I have my in my Python environment. So I will click here. This will open. Will connect my laptop to this environment. So this is a Jupyter environment here, and I will open my my code. So this is the script I'm going to use to train my model. The use case we are presenting today is, let's say, home equity loans use case. So we need to build a predictive model that is able to suggest us whether we should grant or not a loan to a specific person. So the home equity loans are basically the loans you ask when you put your house as collateral. Okay, so these are specific type of loans. But okay, we have our data. Basically, we have historical data in which we have information about the customer. So we know if the customer has defaulted or not, for example, and this is exactly what the bad variable is saying. 1, of course, if the customer has defaulted, 0 if not. So the model will be based on this type of data. The script is very long, so I will be very, very quick on some parts, but don't worry. The point is we are training a model here, and we are saving the training code and the score code in order to be then moved to the, let's say, model governance environment. So first, this is, of course, a Python environment. We need to import some libraries. Okay, so we see here scikit-learn and others. We connect to our data. In this case, we're using a MongoDB container in a database. So we need to connect to the container and fetch our data. So this is just a glance of our data set with all the variables that we saw before. Then we do some data manipulation part. We declare variables. Maybe we have some. We do some. We are imputing the missing values basically here. One hot encoded for the class variable, okay. And then we finally get our ABT. Okay, you might also want to do some data exploration. Again, here, for example, we see the distribution of the bad variable. We see that I would say 80% of the data has a bad variable equal to 0. So the customer hasn't the customer haven't defaulted, right? And okay, some other information we might to need. Okay. Next, we train our model. So first of all, we look at maybe some more traditional models. So we train a logistic regression, decision tree, random forest, and gradient boosting. Okay, so we build our pipelines and we fit all of these models to our data. And we compare them and we see that, for example, the random forest is the best model on the looking at the performances on the validation data. We have the ROC curve, which is higher for the random forest. So currently, this is the best model, right? Then we also decide to challenge all of these models with, let's say, a different model. We use the XGBoost library. So this is, let's say, an advanced version of the gradient boosting. So we train this model as well. We check whether we overfit the model. I would say, looking at this plot, not that much, so we can be satisfied about this model. And then we compare the new model, the XGBoost, with the two best models that we got before. Actually, what we see here is that the random forest is still the best model, but now the XGBoost is the second model here in terms of performances. So what we decide now is that we want to keep them both. We want to maybe take the random forest as our champion model, so the model that we want to deploy, but we also want to have another model, in this case would be the XGBoost model, as a challenger. So this would be our backup plan in production in case the first model, the champion model, performances are not what we expected. So we decide we want to save them both and send them to the model governance environment. So now we start doing all the steps that are, let's say, usually related to the machine learning engineering part. So we build the pipelines for the random forest and for the XGBoost that we just save this code, okay? So we build that for the random forest XGBoost. Maybe we test them before actually putting them in production, so we're sure the code is running. And then the last step is basically taking all the information that we need, maybe some metadata about the model, the package version, the score code, the model pickle file, but also if we want also some information about the fit statistic of the model. So we generate all of this information and we save them into our repository. To do that, we are going to use Viya Py. This is a specific library provided by SAS for Python users. So we can use the function provided in this library to create all of these objects, right? And okay, I will skip this again. But basically, at the end, you see we are also saving the training code, the score code, and the information about the fit statistics. At the end, we zip everything, all the information in a zip file, and we save the zip file to a specific folder. So actually, I forgot to run this notebook. Okay, this will run. It will take a couple of minutes, maybe. So I didn't do that before, but trust me, this will run fine, and we will create all of this data. Okay, and this is the end of the first part. So the data scientist job is finished now. We have trained our model, we tested our model, and we have created all the requirements of the files that we need to then move to the next stage. So you see now the notebook has run fine, so we can be happy about that and move to the next part. So I go back to the presentation. So right now we are here, basically. We said we have trained our model. And so we're ready to move to the next part, so the model deployment phase. So let's get into that. Okay, so now our attention actually will be on the model deployment side and the model governance aspect, as we said. So basically here we will see how we can deploy our model using CI/CD tools, so following again the ModelOps principle, but also how we can monitor our model over time, so we are sure that the performances are not degrading over time. And if that happens, actually, how can we quickly adapt our process and change our model? So I think you remember, this is the same slide we saw before. Now, of course, we have moved to the model deployment side. So now we will take the score code that we generated in this phase, and we will apply it to our production environments. So to go from model dev to model deployment, we can use different tools. Usually for ModelOps, we use some CI/CD tools. Hans mentioned Jenkins at the beginning, so we will see that in the demo. But actually, the problem is, even if you deploy the model, your job is not done yet. You need to make sure that the model performances are, let's say, stable over time. So what do I mean by that? So imagine you have deployed your model. You are in Q1, so maybe after the first 3 months after you deploy the model, and you got the new data to score with the model. And after that, you can start monitoring your model. Basically, what you do is you take, after you see the actual results, so the true label, and this maybe might happen after some time. Maybe the actual results might be visible in Q2. But after you have the true label, then you compare how was the prediction compared to the true label, okay? So in Q1, we can see that the model, imagine that the green stars are when the model says, okay, you can grant a loan, and the red one is do not grant a loan, okay? And after that, looking at the result, we can say that, okay, the model performance was pretty good in Q1 because we almost got everything right. Then we start doing the same process in the other quarters, so Q2, Q3, and Q4. And we start noticing something, that the performances of the model compared to the true level is not good anymore, and is actually decreasing. The performance is decreasing over time. So maybe what is happening here is that we have scoring the model in some different data. Maybe the market conditions are different now, and our model cannot be as good as it was before when we first trained the model, because maybe the training data now are very different from the data we are seeing in Q3. So what needs to happen now is that we also adapt our model to the new market condition to have a stable performance over time. And actually, this is what usually doesn't happen in many companies. So maybe they spend a lot of months training their models, and they consider the job to be done. The problem is that if you don't then monitor your model over time, you don't get the value, you don't generate value out of the model, because the performances might be lower after some period. So we have to be able to monitor these performances. Now, there are different ways to do that. Here is just some example. First of all, we can detect and quantify the shift in the data. So just looking at the data that we are scoring. So here we don't need the true label. We can check if the variable distribution for the predictors is changing over time. So if we have different values, we can spot them using something like that. So we see if for example, a specific variable values is changing over time. So the different quarters here, you can see that, for example, in Q4, we have a quite different value that we have in Q2, for example. Then we can assess the model performance. And here actually is where we need the true level, right? So we can have different metrics here. For example, ROC, if we're using a classification model with a binary target, ROC is simply plotting the specificity against the sensitivity. Basically is a measure of the accuracy of the model. And if we see something like that, across the quarters, the curve is going down, then we know that the performances are not good anymore, and we have to do something. We have other metrics like the lift curve. When we compare the model to a baseline model, Kolmogorov-Smirnov, we compare the cumulative distribution of the target events. Okay, but again, all of these reports and information are needed for us to understand if the model performances are going down. And after we do that, after we analyze all of these plots, what do we have to do? Basically, we have to decide what to do with our model. If the report says that everything is going fine, we can keep using the model also after 1 year. But then we can also decide to maybe swap the model and use the challenger model, for example, because we see that the performances are better. Or we can simply decide to retrain the model with new data. So this is usually the easy, some easy decision. So when you decide, for example, to retrain, it can be very, very quickly to do, and there are no many problems. But if you see that maybe the performances are even lower than you expected, maybe you have to redevelop your model. So maybe you start the analytics process from scratch. You take the data and maybe you train a different type of model. And of course, if you consider this number to be the effort for you, this could be higher, right? Or eventually you can also decide to completely retire the model, reconsider the business objective, and okay, this could take some time. So based on the model performances plot, we have to take some decision on our model. The important thing for you is that you should have a process that is well structured. So as soon as you get and you spot some problems, looking at the performance monitoring plots, you can take the right decision based on that information. So we will see all of this, what we saw together in this second section, now in the second part of the demo that we will show by Hans. So I will give you back the word, Hans, for the last 15 minutes of the presentation.
Okay, thank you. So can you share my screen again, please? Yeah, thank you. Okay, let me pick off where Matteo stopped. I'm back in a Jupyter notebook here, and I'm basically doing the final step of what typically a data scientist would do after he has reached a certain, let's say, stage level with his work. I'm checking in my codes to a Git repository. That's a quite natural thing. And we delayed that a little bit for demo purposes, because what we have done here is we have connected our Git system to an automation server. Yeah. And I'm just switching over to. Oh, I'm sorry. You didn't run the code, isn't it, Matteo?
I did actually.
You ran the code?
Yes.
So the Git didn't have anything to do. So oh yeah. Let me try. I think I missed this step. I'm sorry. Yeah, I'm sorry. That was my fault. I missed the push step.
Don't blame the data scientist.
Never blame the data scientist. Yeah, okay, sorry. Actually, we connected both systems. So the code repository is connected to an automation server. We use Jenkins here. And actually, this is to showcase actually the importance of automation. Yeah, for this ModelOps process. What we are running here is a set of series and tests, and some of them are already have been mentioned by Matteo just a few moments ago. What we want to do is we want to do kind of a little bit of a, let's say, quality assurance. Yeah. So if you check the headlines of these steps in the pipeline, you can already get a feeling for what we are actually doing here. We are doing static code checks. Yeah, we are running a linter, a Python linter on the code. We are validating that all the necessary files have been checked in case the data scientist missed something, he forgot something. But we are also doing, let's say, more sophisticated tests, tests that are more of a statistical or value that already give us some insight on the model performance, on the model quality. And the idea here is that we only accept this model to be pushed into our central model repository if that model complies to all of our coding on all our quality standards. And for example, this time Matteo did a good job. Yeah, so this push actually worked, and the model got pushed into our repository. But back in October, he was not so. He was not working cleanly, and so we rejected his code. Yeah, we didn't. We said, "Oh, Matteo, sit down, try again. Yeah, it's not good enough." Yeah. Okay, now this time it worked. Let me move over to the model management tool that I mentioned in my introduction. This is a tool provided by SAS. This is SAS Model Manager, and if you check the numbers here, we just got a new model. Huh? We were at 7, now we are at 8. And if I sort this by time, you see that Matteo just checked, or we just checked in a new analytical model. This is on a project level. Stepping down on a model level, you see that we have actually checked in 2 models. Yeah, this is what Matteo mentioned. We have the random forest and the XGBoost model, and we can even compare them inside Model Manager. This is something that Matteo has already done. Yeah, sure. But you see, I'm a different person. I have a different role. Maybe some time has passed, whatever. So I might want to check these results. And by looking at these charts and by the different KPIs that we have collected, I can say that, yeah, Matteo was right. The random forest is really the better model. Okay. Now is the time when we actually think about pushing this into a production environment. And you might have seen that so far. We are working in a fully containerized environment. And if we talk about publishing and deploying a model, what we actually mean is creating a container image and deploying that to a Kubernetes cluster. Okay, so let me do this step. So I've highlighted the random forest, and I'm going to publish that now. Oh, sorry, one step I missed. We just found out that the random forest model is the better one, so I have to highlight this one. I have to tag this model as being the champion model. Yeah, so basically I have to tell the system which of both models I really want to publish. Yeah, so this is just some metadata labeling that we attach to this model. So let me do this step to highlight it again. I'm publishing it. We do support a lot of publishing destinations. I'm choosing the container one here. We also could deploy this to, let's say, a database like a Teradata system. We could deploy it to our own engines, of course, and also to a Hadoop system if we want to, or to edge devices for streaming analytics. In this case, this step actually creates a container image. So this container image has a Python runtime. We are adding our model, the random forest, into that container on top of that Python runtime. And we are also adding a small REST interface into that container. And that REST interface will be the communication channel that we have, that any client has, to use our model later in any business scenario. Okay, so it seems that we have built our container image. I can even validate that. I think I will skip that step in the interest of time. But I think it's worth mentioning. So what I can do here is I can run some tests on my model. These are more, let's say, statistical tests. I could validate again if the model is good enough. But I mean, we already did that in our Jenkins pipeline. But the publishing validation check is even, let's say, more valuable, because this lets me test if the container image has been built successfully. So this is basically simulating a client sending some data. I'm just selecting the data source here. This is just sending some data to the container image, to the container instance then, to see if that model really works. Yeah, does the REST interface work? Is the code okay? Do we get some success responses? Yeah, and that's a very valuable test for me, because in my role, I'm maybe not the Kubernetes admin, so I have to trust that this container will work. And as we can see, it seems to be the case. The status is green, and I even can check the results. Let me see, this is the resulting table. We see all the input variables, and if I scroll to the right, you see we also see some scored values. So it seems that the Python model inside our container has really produced some results. Okay, that's okay. Now we have a model. We have deployed it on a Kubernetes cluster. In that case, we have published it. Now let's assume some time has passed, and now that what Matteo has talked about in his section, that happens now. So over time, our model might get worse. Yeah, it might degrade. The performance might get down because market conditions change or whatever happens. And as Matteo said, it's important that we can check this. Yeah, so we need a way to get that information back to our data scientists or back to the people doing the model governance and the model monitoring. Now, we don't have that feedback, that kind of feedback data for this model, of course, because we just published it, isn't it? So you need to wait for a second, yeah, for some time before you get that feedback data. We did that for an older version of this model. And what we want to show you as a final step here is actually that we can collect that feedback data in an automated way, and we can use that to automatically generate performance reports. So this is what you see here. Yeah, this is a sample for 4 periods. That could be months, could be weeks, could be quarters, whatever you define as a period in your business, and it shows how the model has changed over time. Yeah, and if you're a data scientist, you will easily see that the model has gone worse over time. Yeah, so the quality of the model has decreased, and I could now actually add some alerts or triggers to that to that process to make me aware of that fact. So now we are looking at this in an interactive way, but there would be ways, or there are ways, to also automate this step, so that you know when it's time to retrain the model, for example. Okay, so that concludes our demo, and we are nearly out of time. So let me go back to the slide deck. This is our final slide. It's our summary. What did we show to you? You've seen us working in containerized workspaces. Data scientists are working in their own data, in their own workspace. These are Docker containers. We can provide any type of language. Yeah, SAS, R, Python, Julia, whatever you like. I mean, this is very well suited for that type of isolating workload, the Docker containerization. You have seen an automated model validation pipeline. That was the piece running in Jenkins, where we checked the model before we accepted it for our central model repository. That was the next step that you saw. We have a way of centralizing models. Yeah, keeping a version, keeping a history, keeping a lot of metadata of your models inside Model Manager in SAS. And then finally, if you collect the data, the real data, the real world data, we are able to present you with model performance dashboards that give you a chance to react on a degradation of your models over time. Okay, I think we are nearly done.
I think, Hans, we have a couple of minutes more. Is it possible to see the model running in the application? In the application that you presented at the beginning?
So let me get back. That was our model. And this would be, that's our client. Yeah, let's say that's the client. And Peter from New York, you might know him, huh? He is requesting a credit loan, and he gave us a couple of input. Yeah, for example, his number of credit lines, and based on that input, we are saying, oh, that's good. Yeah, so this is a response that you see. Yeah, that's good. Let's give him a credit loan. But if Peter changes his mind or corrects his input, yeah, that might change. Yeah, so you see the traffic light switch to yellow, and that's because his input got worse. Yeah, and that's a reaction, that's a decision that is based on our model working in that Python container.
So what we have here in the backend is the same model I trained 10 minutes ago, and now is deployed and used by this application, right?
Exactly. And I would be the account clerk now in a bank, for example, and Peter is sitting next to me, and I have to tell him, look, Peter, I'm sorry.
Okay, perfect. I think this is it.